Good morning, students. So, this is our first lecture, and in this session, I will discuss about more about the course thing. So, basically, this course is numerical methods for engineering computation, MA 504. That is a course code, and this course is with 3 credits. And in this lecture, we will discuss about more the course content. And examination pattern, what are the objective of this course, and uh, what are the activity you should do in this course. So briefly we will discuss. So as you know, the course name is numerical methods, but sometimes we confuse with the term computational and numerical. So first we should know what is the meaning of computational and how it is different from numerical things. So if we see computational, that will have the sets of numerical techniques. So basically these computational methods are used to analyze any physical system. So at the end we will have complete information about the physical system of the or you can say the engineering system, whatever we have considered. So in computational method, uh, if you take example like FEM, this finite element method, that is a computational method. So in FEM, we need to implement several numerical techniques to get the solution of the physical system. Like first, we need to interpolate the differential equation in terms of the algebraic equation. So we are using one interpolation technique. After that, once we will have system of equation, then we need to solve. So for solving, either we need to use the iterative or non-iterative method like Gauss elimination, or non-iterative method like successive over relaxation or Jordan iteration kind of thing. Then numerical integration, also we need to use this Gauss quadrature. So basically in computational method we will have a set of different numerical technique that we use to get the solution. But in numerical technique we will have some approach to get the solution of particular differential equation in terms of numbers. So like if we have the algebraic equation like polynomials, then algebraic equation or polynomial, then we need to get the roots. So for finding the root, we have the Newton-Raphson method. In the same, for getting the solution of algebraic equation, we will have this Gauss elimination method. So these are the numerical techniques. And numerical method also deal with the study of convergence and numerical analysis. So all these things we will discuss in the course in detail form. Now, why this numerical method is required? What is the need? So if we see any physical system and an engineer, we need to get the behavior, we need to predict the behavior or solution of the particular physical system. So we have different approach for the analysis, like experimental thing. So in experimental we need to replicate behavior of physical system. Like suppose we have one material, like suppose we have taken this pen. So I would like to know the behavior of this pen when we apply some kind of writing purpose. So at the nib we will get some kind of stress because of writing. So basically it will be some shear stress will get developed during the writing. So this behavior we need to get. So for that we need to do the experiment. So for experiment, what we need to have, we need to get some machine. So by which that machine we can apply similar kind of effect over the nib. We need to have one pen, that is a specimen, and some device we need to get record the data. So basically we need to have multiple resources for experimental analysis. Similarly, for an analytical approach, basically it is closed form solution. So we will get the exact solution for by using the analytical method. But the technique or approach is quite complicated. If problem is simple, then we can get directly solution for the things. But if we have the complicated boundary condition, environment, complicated you can say geometry, complicated behavior of the material itself. Uh, so this analytical solution is difficult task. So we can't implement this thing for real life engineering problems. So ultimately we will have option like numerical things. So in numerical, uh, we need to get the solution of the government this system. You can say system equations uh, in form of some number, and for that we implement either this approximation, interpolation. Sometimes we need to do the curve fitting. Sometimes we can get the behavior by solution of the partial differential equation or ordinary differential equation by some means. So if you see the numerical method advantage, it will be applicable for all kind of the systems irrespective of domain. So it may be the civil problems, or you can say this electrical problem, mechanical problem. Everywhere we can implement, either it is a chemical thing. So anywhere we can use this numerical method. And there are some points like so if system is too complicated, you already discussed this experimental analysis is a little bit difficult due to the resource kind of thing. And if a mathematical model is complicated, so if system is complicated, mathematical model or which represent the particular system is also complicated. For analytical solution is difficult. And sometimes if we consider geometry that is complicated, then also the analytical solution is not easier thing. So we can move to other numerical methods. So the major content of this course is to solve ordinary differential equation and partial differential equation. So we should know what is the difference between ODE and PD. So most of you may know, but for other students, I would like to just clarify. So this ODE and PD is related to the independent variables. So in any differential equation is uh, the dependent variable is related to the only one independent variable. So you can see here y is related to the x. Okay, y is the dependent variable and x is the independent variable in this equation. So here we have only one independent variable in this differential equation. If we move to the second one, then we have the time as an independent variable. So only one independent variable we have. So it comes under the ordinary differential equation. But sometimes, due to the nature of the problem, we will have the multiple independent variable like this heat equation. This temperature thing is dependent upon the time as well as the geometry. So two independent variable we have. So it is the partial differential equation. Similarly, in wave equation, this thing is dependent upon the time as well as this uh, geometrical domain. So two independent variable we have. And in Laplace this equation we have the two independent variable, but both are the geometrical things, but one is the x dimension and another is the y dimension. So the dependent variable is dependent on the x as well as the y. So two independent variables, so that's why it is a partial differential equation. So in solution of the differential equation, we will have some you can say system equations and some boundary condition we will have. So we should know the boundary condition, and based on the boundary condition we can classify system of equations. So here in this equation we have the second order derivative equation that represent the one dimensional, you can say, bar problem if we consider the structural thing. And it is also represent the heat conduction equation for thermal, or it can be you can say uh, this you can this electricity problem, like that is related to the voltage and current, so that is also represented by this thing. So in this thing, what is the boundary? So boundary condition is like this, whatever the dependent variable is there, that is related with the geometrical condition. And two geometrical condition we have. So one is if geometrical thing is vary from 0 to L, and if geometry you guess well geometry condition at x is equal to 0, then y is value is given, and similarly the derivative of this primary variable is given at the another domain, geometrical domain. So the things are like the boundary condition, like the value of dependent variable is given in terms of the geometrical boundary thing. So that's why it's called as a boundary value problem. The second thing, classification, we have initial value problem. So here we you can see uh, the boundary, you can say the boundary condition, or you can say the value of the primary variable is given in terms of the time. So if you can see this primary variable is u, that we need to get value after solving of this equation, and this u is dependent upon the time, and this time scale we have 0 to capital T. So if we take the time as the initial point, that is 0, so the value of dependent variable at the initial point is given. So that's why it's known as the initial value problems. Sometimes we will have the mixture of initial value problem and the boundary value problem. So the condition would be given. Condition means the value of primary variable will be given in terms of the time as well as the domain, geometrical domain. So it will be known as the boundary initial value problem. Sometimes we need to do the model analysis. So for model analysis, solution will be given in terms of the eigenvalue, just like if we consider the vibration problem. So natural frequency we will have in with reference to the modes. So for different modes we will have the different natural frequency. So in this case we will have a solution with the different conditions. So solution we will get in terms of the lambda, and this thing will be get changed. Okay, so it's known as the eigenvalue problem. Now we have some example, system example, and this from this slide we will able to get know how we can get the system equations. So like this chemical engineering problems we will consider. So here we will have the reactors and reservoir, and our objective is to get the flow rate of the particular chemical constituent with respect to time. So for that we need to implement the conservation of mass, and by using this principle we will have the mathematical equation, and that mathematical expression we need to solve. And for solving this mathematical expression we will use numerical technique. Similarly, in civil engineering problems, we will have some kind of structure, and here we have taken a structure which in form of truss. So basically, to get the solution in like what are the force in the particular member, and what will be the stresses in the particular member. So for that we need to again apply some kind of principle, and once we implement the principle we will have the some set of equations, and that we need to solve. So here we implement this conservation of momentum, and we will have the force balance equation by implementing this thing, and then we will have system equation, and those system equation we will solve by using the numerical technique. Similarly, mechanical engineering system, uh, we will have some kind of machine, and here we have taken locomotive like a car, and there we will have the multiple component which will connected to each other, and each component will have their different characteristic. So here we will have like shock observer, and some other component which will be in the motion. So basically, to get the forces and individual member and stresses, we need to get the conservation of momentum, and after that we will have the force balance equation, and that equation we have to solve to get the force. Further we will have the geometrical information like what are the cross section area, what are the length, all these things, and once we use with the force, individual forces, then we will be able to get the stress kind of thing. So stress information we will have. Similarly, we will have the electrical engineering circuits. So there also we can implement this numerical methods. So here we have example that is the voltage resistance circuit. We can also consider uh, this LCR circuit. That depends, and basically we will use the conservation of charge and conservation of energy principle, and then we will have some sets of equation. That sets of equation we will solve. So basically, irrespective of your stream and domain, we we can implement this numerical method to get the solution. So by using the your this domain information or knowledge, you need to get the some system of equations, and for after that we need to implement the numerical method technique to get the solution. So this numerical method can be useful for all streams. This will be the course content for this course. So um, uh, whatever technique we will see or learn from this course, that we need to implement by using some programming skill. So obviously at the end you will be equipped with some MATLAB programming skills. So irrespective of you have exposure uh, or hands-on on this MATLAB programming, we will have some sessions. So you will be able to write the MATLAB program from very basic. So few lectures we will have on syntax and numerical analysis by using the MATLAB program. Then we will move toward the linear system of equation. So once you will have the system of equation, how to solve. So for this thing, we will implement some algorithm, and we will see what are the algorithm, and what are their characteristics in terms of the advantage and disadvantage, what are the computational costs associated with it, and what are the steps. All these things we will see, and we'll try to implement by using the MATLAB programming. Then we will have some algorithm based on the eigenvalues and eigenvectors, and we will move towards the root finding techniques. So that is for polynomials. For a lower order polynomial, is it easier to get the roots, but for higher order it's difficult. So we will see what are the techniques to get the roots of the higher order polynomial equation. So by using Newton Raphson and another technique. Sometimes people do some kind of experiments, and they got some characteristic of the system itself in terms of the data, but we need to generalize those data in terms of the mathematical model. For that, this curve fitting technique is very beneficial. So we will see how to use this curve fitting technique by using the computational means MATLAB programming. Then we will further move toward the finite difference interpolation. So this finite difference is very useful for the people who are working on thermal and fluid flow problems. And the interpolation technique we are using in finite element method. So we shall have idea about how to use this interpolation technique and how it is beneficial for the finite element method, and how we can choose the different kinds of interpolation by using the programming skill. Then the differentiation and integration we will see, and this is also useful for the FEM method. So that example I am taking the one of the example FEM. It is also useful for the different schemes. So this in FEM we are using the Gauss quadrature, and other techniques are useful whenever you have suppose some data you have collected and you want to get the area under the curve whatever you obtained from the analysis of mathematical model as well as from the experimental things. So all these things we will be able to see, and obviously OD and PD solution we will see, and at the end we will get the error analysis of the uh, numerical methods and how to optimize this algorithm by optimizing the minimizing the error as well as the optimizing the computational time. So all these factors we will see. Yeah, in this course we shall use two books for the course content. One is Applied Numerical Methods with MATLAB, written by Stephen Chapra, and second book is Numerical Methods by D. Hoffman. So these two books I shall refer, and soft copy is also available for these two books. So you can Google it and download as per your convenience. And for MATLAB syntax learning, this MATLAB book by Rudra Pratap is very basic. You can refer this one, and soft copy is also available for this thing. And obviously, if you uh, do this course, then we need to evaluate your gained skill and knowledge in terms of some marks and grade. So we will have this assessment scheme. So 30% weightage we will have for assignments and tutorials, and we will have one quiz which will have a weightage of 20%, and in term exam we will have 50%. And I should, although this uh, lecture video will be uploaded on the particular platform, and we will not have the live session, but you should see all the lectures, and that from attendance will be counted in that way. So 90% I am expecting attendance in terms of viewing of the video lectures. And the lectures I will upload on Monday, Tuesday, and Thursday according to timetable, and we will have weekly one session for doubt clearance. So if you are feeling any problem on a specific topic and you want to discuss something related to this course topic, then we will have one weekly session at 10 a.m. So. Uh, Everybody who do some work should get rewarded in terms of some knowledge or skill gain terms. So what are the objective of this course? So basically at the end of this course, first thing you will be able to write the MATLAB programming. So this is the one other skill, and in terms of knowledge you will be able to uh, implement this different numerical techniques for any kind of problem, this engineering problems. So that you can implement in terms of solution of the differential equations, in terms of algebraic equation, in terms of numerical integration. So any kind of numerical, the major numerical things you'll be able to implement in your targeted uh, stream or domain. So this is the course objective. So with this, I would like to thank all of you, and from the next video lecture we will start with the MATLAB syntax pro and their programming. Thank you everyone.